do a record like I do right now. So make sure that you check previous lecture recordings, see what we did together in class, and do same problems again. And if there's anything that you need my help with, just tell me what problem I should do for you from these sections. I like to start with exercise 79. That wants us to factor by grouping. So grouping deals with first and the third term, and then the second and the fourth term. So what I can do is take out A and have in the parentheses A plus B. And then for the second group, I also need the same exact A plus B in the parentheses. So it looks like I need to take out -4, and there is going to be B plus A and the second group in the parentheses. And we already noticed that A plus B or B plus A, that's the same exact thing, because I need to have exactly the same parentheses so I can factor it out. So I can put A plus B on the outside. And then from the first piece, I have A, and from the second, I have -4. And what I just produced is multiplication of two factors. So it's called factoring. And that's all we have to do in this exercise. So factor by grouping. Please notice I put together first group with term 1 and 3. Well, simply because with terms 1 and 2, I could not see anything that was in common. Let me do 81 exercise, one more here. It looks like with 81, I'm going to group first two and the last two. So what I'm going to do is take out letter X from my first group, and there'll be a sum of A and a B in the parentheses. And then I need again the same exact parentheses, and looks like I just need to take out negative, right? Or -1. So there'll still be A plus B inside this parentheses. So X minus 1 will be my factor here, and also parentheses A plus B. And again, good thing about this book that we have answers right next to the exercise. So you can see they wrote it as A plus B times X minus 1. And it's the same thing, because when we multiply, we can multiply it one way or the other way. It doesn't really matter. So group and take out what's in common to produce the same parentheses. The next section is talking about a very special formula, which you can check out by multiplying X with X, so you get X squared, and Y with -Y, you get a minus Y squared. And it turns out that everything else will cancel. Remember, we used to so-called FOIL, so you multiply the inside terms also and the outside terms, and in the first term product will be YX, and in the second on the outside will be negative X and Y, and YX and XY is the same thing, but one of them has a negative sign, and that's why I can cancel both of them together. And that's how we produce that nice formula. So whenever we have a difference of two perfect squares to factor, you write it as a X minus Y multiplied by X plus Y, or X plus Y multiplied by X minus Y, because this is going to be the same exact result. So what I will do is use this formula in a section, and let me do some exercises here. Let's say problem number 21. It says, how about if you try to factor something like x squared minus 4, which I could write as a 2 squared, right? 2 times 2 is 4. So according to the formula above, I can write this as a product of x minus 2 multiplied by x plus 2, right? So difference of these two and a sum of this same two terms. How about number 28? That says, what if we have 144a squared? Well, I can treat 144 as a 12 times 12. So the first piece will be 12a, which is squared, and minus b to the fourth, which is also a square. I can say it's a square of b to the second power. So without squares, I'm going to have 12a and b squared, right? So I put 12a minus b squared is multiplied by 12a, I forgot a, by 12a plus b squared, just like that. So it turns out those are two perfect squares. And this is great. So it looks like we have a way to factor. So let me try exercise 39. Again, in these sections, they have lots of exercises, and I guess you don't want to stuck with these exercises for too long. You could just do a few problems and move on, and not to waste much time doing the same thing over and over again. And that's why I skip a few and then do another one. Like next group of problems deals with common factor 2 that I just factored out. It turns out whenever you are trying to factor something, you start with a common factor first. And once you took out that common factor, then it looks like we have the same difference of two squares, x and 12, right? So I can put x minus 12 multiplied by x plus 12. So we just used that same formula again, the formula that factors two perfect squares. And that's it. So whenever you have something in common, well, don't wait for too long, take it out. How about problem number 57? Is there anything in common? Well, looks like yes. I can take out power of x, the power that I can take. Oh, that's another group of exercises. Let me hold on with this because I think I will do it a little later. I want to today concentrate only on the squares. So let me grab a problem from this previous set of exercises. Maybe I'll just scroll this down a little bit so we can. Okay. So how about 46? Here's the, looks like messy exercise. But if you check out what's in common, you will see that there is really not much to worry about, but take out 16, right? 16 is factor of 64. Now from a to the power of 3 here, and another power of a, which is 2. Oh, first is a to the fourth. So I take the lower power of a, which is a to the power of 2, right? Because that's in the second term. Then I go for b's, and looks like there's b by itself and b cubed. So I can take out that lower power, which is b. We'll always factor out lower powers, and c power of 4, because the other is 8. So what's left in the parentheses? Well, looks like a to the second power is here, because I took out a squared. B to the power of 2, right, is also here. And c to the fourth is gone, so that's all we're left with from my term. So you can check out if you multiply these back, you should get back the original things, such as b squared, and b is b cubed, and a squared is a to the power of 4. Now, in the next term, we're left with 4, because times 16 is 64. A squared and b are gone, but c was to the power of 6. We take out the power of 4, so it looks like the c to the second power is what we left. And this is the parentheses I want to factor. So I want to write down that same 16a squared b and c to the 4th. That's already a factor. But now I'm going to use the same exact formula that we just utilized and break my parentheses with a difference and sum of terms that look the same. It's AB minus 2 times C. And for the second, it's also going to be AB and 2 times C, but with a positive sign, right? So we have factoring in here. And this is great. And I guess that's all we need in this group of exercises. Now, here's the word of caution that if you have a sum of x squared and y squared, then you cannot factor the sum. You say that this is a prime. Prime means cannot factor. If you can factor, then you factor it, but if you cannot, it's prime. So notice the formula above in the upper left corner that we have been using today has a difference, not the sum. So if you have a sum, then you cannot factor, just like in exercise 75, whenever they say try to factor sum, well, since you cannot, then you say it's prime. How about exercise number 31? In this exercise, we have x to the 4th and y to the 4th. So I can treat them as squares. So x squared to the second power minus y squared to the second power. So I'm trying to use the new favorite formula and write this as a product of x squared minus y squared. So those powers of 2 on the outside, I just throw away and write this as if I had the difference in the sum of those squares. But then I can work out factor my first parentheses because it's a difference of 2 squares. So I can write this as a x minus y times x plus y. And just to copy that x squared added with y squared by itself, just like that. And that'd be the answer. It's interesting, right? So maybe you can also try to factor something in an analogous way. Maybe I can produce the problem for you so you can try. So how about if you try to factor 81 x squared minus 9 y squared? Could you factor this as a little quiz for today? So factor the difference that I just produced here for you. So that's our little quiz for today. Just please don't hurry. You have plenty of time. And as usual,